Hello, good morning, class. How are you today? All healthy? May you, wherever you are, might be in a good health. Okay, before we start learning today, it will be nice to start with prayer so that our learning activities can run smoothly. For the prayer I lead, pray begin. Praying is over. Okay, the saying Gus don't know, then don't love. Let me introduce myself to you. My name is Kadek Ariantini. You can call me Ari or Ariantini. Anyone know what we're going to learn today? Yes, that's right. We will learn about sets, precisely the various of sets. Okay, before that anyone knew what a set was, what are sets? A set Okay, a set is a collection of objects whose elements and members can also be clearly defined and can have a definite truth value that is true or false or not relative. For example, number one, A equals the set of primes less than 10. Okay, surely you can guys. What are the prime numbers that are less than 10? Yes, that's right. Numbers that are less than 10, that are 4. This is right. A equals brackets 2, 3, 5, and 7. Okay, the next, for example, B. B equals the set of names of days where prefix is the letter S. So what are the days that prefix the letter S? Yes, that's right. That there are Saturday and Sunday. I'm sorry, Sunday and Saturday. Okay. Then okay. This is one example. M equals sets of beautiful students. Uh, then is this M a set? Yes, that's right. This M is not a set because students are relatively beautiful and have no right or wrong grades on and no definite answer. Okay, let's just go try to the various sets. The various sets are defined into several types, namely uh, number one, empty set, universal sets, number set, finite set and infinite sets, countable sets and uncountable sets. Okay, next. I'm sorry, this is wrong. Okay, number one, empty set. Empty set is the unique set having no elements, its size or cardinality. Count of elements in a set is 0. Empty set marked with symbol empty set or brackets, not membership in this set. Okay, for example, B equals the set of numbers that are divisible by 2. Okay, the set of numbers that are divisible by 2 is not element. So this answer to B. B equals brackets. Brackets. This is brackets, not elements or not membership is this sets. Or B equals empty set. Next, number two universal set. Universal set is a set which contains all objects including itself. Universal set marked with symbol S. Next, number three, number set. Okay, the set of numbers consists of the following. Number one, set of natural numbers, set of whole numbers, prime number set, even number set of odd numbers, and the last composite number sets. number one, this is a set of natural numbers. The set of natural numbers is symbolized by the letter A capital. The set of natural numbers is an infinite set. Okay, for example, this is A equals brackets 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and infinite. Okay, the next is set of whole numbers. The set of whole number is the part of the number system in which it includes all the positive integers from 0. Okay, this is set of whole numbers, positive integers from 0 to infinity. This number is often denoted by the capital letter C. For example, C equals brackets 0. Okay, includes all the positive integers from 0. From 0. Okay, from 0, 1, 2, 3 to infinity. So 0, 1, 2, 3, 4, 5, 6, and infinity. Next, prime number set. A prime number set is a natural numbers of more than one that is not the result of times from two smaller natural numbers. The prime number in his writing is denoted by the letter P capital. For example, P equals brackets 2, 3, 5, 7, 11, 13, 17, 19, and infinity. This is number of more than one that is not the result of times from two small natural numbers. Okay, next, even number set. An even number set is a set of integers that are divisible in two. The set of even numbers consists of positive even numbers and negative even numbers. Okay, for example, this is example about positive even numbers. G equals brackets 2, 4, 6, 11, 8, 10, and infinite. This is integers that are divisible into. Okay, next, for example, about negative even numbers. This is G equals brackets is this is infinite to negative 8, negative 6, negative 4, and the last negative 2. Again, next, set of odd numbers. An odd number is any number that is not a multiple of 2, so it will not be exhausted if divided by 2. The set of odd numbers consists of positive odd numbers. Okay, this is positive odd numbers and negative odd numbers. For example, okay, this is 2. For example, this is the first. For example, of positive odd numbers, and this is for example of negative odd numbers. Okay, this is G equals brackets 1, 3, 5. 7, 9, 11, 13, 15, and infinite about number that is not a multiple of 2, or this is not be exhausted if divided by 2. And this is, for example, G equals brackets infinite to negative 9, negative 7, negative 5, and negative 3, and the last negative 1. This is negative odd numbers. Okay, next, composite number set. A composite number set is a natural number that has more than two dividing factors. Composite numbers are natural numbers except the numbers 1 and prime numbers. Okay, for example, K K equals brackets 4, 6, 8, 9. This is numbers, not prime numbers. except the numbers 1 and prime numbers. Okay, next, integer set. An integer is any number including 0, positive numbers, and negative numbers. It should be noted that an integer can never be a fraction, a decimal, or a percent. Okay, for example, z equals brackets infinite 2, negative 2, negative 1, 0, 1, 2, 3, 4, 5, and infinite. Okay, this is negative numbers, this is 0, and this is positive numbers. Okay, an integer is any number including 0, positive numbers, and negative numbers. Next, rational number set. In mathematics, a rational number is a number that can be expressed as the quotient or fraction p per q of two integers, a numerator p and a non-zero denominator q. For example, non-zero, this is a denominator not equals, denominator not equals 0, denominator q. For example, negative 3 per 7 is a rational number as is every integer. Okay, for example, 8g 5 equals 5 per 1. And q equals brackets p per q, uh, p per q, this is, I'm so sorry, ag 5 equals 5 per 1, and q equals p per q, where p and key element integer elements, and key and q is not equals 0. It's not equals 0. Okay, next, finite sets and infinite sets. Finite set is a set whose many members are finite, that is an empty set or set that has n elements. For example, of finite sets, A equals brackets A, B, C, D. Break. Okay, this is not infinite, This is finite sets. Or B equals not empty sets or brackets, but not membership in sets. Next, infinite sets. Infinite sets are the numbers of elements in the set is not countable. Thus, infinite sets are also known as uncountable sets. For examples, even numbers, odd numbers, integer, rational numbers, and so on. This is even numbers is infinity, odd numbers infinity, integers infinity, rational numbers, and so on. Okay, next, countable sets. A set is countable if it has the same cardinality, the numbers of elements of the set, as some subset of the set of natural numbers, n equals brackets 0, 1, 2, 3, and infinite. Equivalently, a set is incountable if there exists an injective function as to n from s to n, from s to n. This is s function. I'm sorry. This is injective function s from s to n. It simply means that every element in S has the correspondence to a different element in N. For example, A equals brackets 1, 2, 3, 4, or this is for example number 1, and this is for example B equals odd numbers. Okay, the last uncountable sets. A set is uncountable set is an infinite set that contains too many elements to be countable. The uncountability of a set is closely related to its cardinal numbers. A set is uncountable if its cardinal number is large than that of the sets of all natural numbers. For example, rational number sets. Okay, that was the material about a set and the various sets. Thank you for your attention. Hopefully, it can be meaningful for all of you. Apologies if there is a wrong word. Uh, Thank you. I close with Paramasanti. Om Santi, Santi, Santi Om. See you.